On the 3rd of April of 2025, I presented at the London Kotlin Community. My presentation was held online because of many reasons, but mostly because of the logistics needed to sort out before I could travel to London and be there on time for the meetup. And so we decided that we would do this presentation online. It went really well, and I enjoyed also participating in a Q&A session that was held afterwards. My session was about ways to use Project Arrow in projects, ways to use them in practice, because Project Arrow is a very extended project that has many different features, and we don't use them always, and we may not want to use all of them at the same time. Project Arrow is a library that we can use in our project to enhance the way we do functional programming. But I didn't want to talk about the specifics of the current project I'm using it already in, because of course I cannot talk directly about the implementations that we are using in my specific project in my company. And so I devised a plan. What I wanted to do is to create something new that would be a parallel to what we are using already. And that's why I came up with this project where we are talking about data transmission between spaceships. We are talking about docking a spaceship, we are talking about refueling a spaceship, and we are talking about accounts that may be given to users of that space station, which could be astronauts or anyone who is a part of the crew of the spaceship. So I found the topic to be interesting, and it gives a kind of sphere to what we want to achieve with this project. And so let's get into that presentation and let's see the examples. Let's go through the slides that I also showed in this presentation in the meetup and understand a bit more what Project Arrow can do for us in reality. So let's get into that. Boosting performance and functional style with Project Arrow from a practical perspective, with spaceships. A little bit about me. I've been a software engineer for more than 10 years, and in this time I have developed in different programming languages like Java, Kotlin, Groovy, and Scala, so essentially languages around the JVM, and I am the owner of the YouTube channel JasperTech. I am a certified Spring professional. I'm also a certified Java professional. I am a Kong champion, also recently an MVP. And in a nutshell, this is who I am. So in this presentation, we are going to see very different aspects of Project Arrow, and we are going to see why are we talking about this, how can we apply this, and what are the most useful use cases for this library. So the problems we are trying to solve are, for example, challenges in data transmission. What do we need to do to send data correctly through the wire? We need to think also, why are we choosing functional programming for spaceship data transmission? In any case, any kind of data transmission, why is it important for us to use functional programming? We also need to think, what is Project Arrow and what does it mean to talk about Project Arrow? And why does this work? These are all questions that we are going to answer and topics that we are going to discuss throughout this video. So what are the challenges in data transmission? We need to handle transmission failures. So we need to have a good way of handling errors and a good way to discuss how errors should be handled and where and when can we interpret these errors. Important also is to ensure the message delivery order. How can we achieve a certain kind of order, and how can we achieve the expected result when we are sending messages, especially if we are sending asynchronous messages? What do we need to do to make sure that we get the message correctly from point A to point B? We also need to discuss encoding and decoding data. What does it mean to encode and decode data through the wire? These are things that are important when we are thinking about data transmission. What format are we going to use? Is it gRPC? Is it JSON? Is it XML? Are we doing more innovative things, or are we doing still the typical standard that we are bound to deal with in current applications? Do we want to break through the rules? We need also to think about handling missing or corrupted data. So this is a bit different than transmission failures. Transmission failure is more related to if a message gets delivered. In this case, we are talking about a corrupted data, something that happened through the wire, or perhaps when we are sending the data or choosing what we want to fill in our data, that gets across through the wire and in the reception gets invalidated, for example. So how do we deal with that, and what do we do when the format or the data itself doesn't match the expected results? We need to make sure that we make good common execution that is asynchronous. And the idea is that we will deal with back-off pressure and things like resilience in our services. And what does it mean to send these asynchronous commands to our services that will have to deal with many different requests at the same time? And then finally, we need to coordinate state. If there is a state between the two different ships, what does it mean to coordinate that state? And how can we guarantee that our state doesn't get into a blob of mess? So we need to make sure that if I perform something in a transactional way, and that is already a hint, that the state doesn't get corrupted in any way. So these are basically challenges that we face with data transmission in general. It doesn't necessarily mean that we are going to deal with all of these with these features of Project Arrow, but it does mean that these are things that we need to keep in mind when sending data through the wire. But why functional programming anyways? Why do we need to choose functional programming? And do we need to choose functional programming? Now, one of the things that functional programming relies on is that our data is immutable. And so that means that all through our code, we are able to predict where the data is at. We are able to say that from A to B, through all of these different function calls, our data will not be changed. That is what immutability guarantees us to do. And that is why it is so handy to use with data transmission. Functional programming also relies on error handling without crashes. So this means that there are ways to deal with errors without having to use things like try-catch, for example. Or perhaps even if we use try-catch, that we have an elegant way to deal with the way errors are being thrown. Functional programming works in such a way that it's much more easy to implement things like resilience and automatic recovery. If we think about how we make code, especially if you are coming from a Java background, the old Java background, not the new, because the new is different, but if you come from the standard way of programming in Java, or even the standard way of programming in Kotlin, you will find that doing automatic recovery and making resilient systems can result in a complicated code. It doesn't have to, but this is something we want to avoid. And of course, Project Arrow comes here and fits very well into this part of a feature that we want to add to our project. Functional programming matches really good and fits like a glove when we are talking about concurrency with reduced complexity. In the world of Kotlin, we've got something called Kotlin coroutines. And Kotlin coroutines are ideal when we are trying to deal with concurrency and we are trying to remove complexity. It depends on what we are using. In this case, for example, if we are using Spring, we will still have to use things like suspend, which adds some complexity to the code. If we are using things like Ktor, which are inherently synchronous and are inherently adapted to work with coroutines, then we probably won't even see the suspend keyword ever, which is also why I chose Ktor to use in these examples, so that the suspend keyword doesn't bring some confusion in trying to understand how the code works. Mathematical guarantees for safety. This is something that happens implicitly in our code if we are using Project Arrow and Kotlin in general. And also other languages like Java, for example, also use this. The thing is that we don't think about this. And what this is about is monad theory. We are talking about using functors, using monoids, and using monads in our project. And therefore, we get mathematical guarantees that our code will work. Because monoids, monads, and functors are part of a general mathematical theory that is applied in programming and has been applied for a long time in different programming languages, like, for example, Haskell, which is something that always comes up when we talk about these concepts. But in any case, this is just something to keep in mind when we are working with functional programming and using Project Arrow. Two important examples of these concepts are implemented with option and either, which are also things that we are going to see later on. Declarative and composable pipelines. When we are using functional programming, making declarable and composable pipelines is much easier than using standard object-oriented programming. And that, of course, with Kotlin is enhanced and is made a little bit better because Kotlin is focused on functional programming, but also with Project Arrow we will see functionalities that will allow us to compose different elegant pipelines so that we can get our results and implement the features that we require. Finally, the most important aspect of functional programming is this concept about pure functions. When we are using Kotlin, even just using Kotlin, sometimes it's difficult for us to make code that it's pure. Now, the concept of pure may sound a bit unfamiliar or even silly when we talk about it if we don't know the theory behind what it means to say pure functions. Pure functions are functions that essentially don't cause side effects. They are not dependent on external factors, like, for example, global variables or fields of the class. They basically work isolated, and that means that when we call these functions, we are sure not to affect any kind of state that our instance may have. And that's what means here to be pure. And this is important because of predictability and all sorts of different benefits that we will reap from using this. But what is Project Arrow? Project Arrow is a functional programming library, I just put the definition here, for Kotlin that provides tools for typed error handling, concurrency, resilience, optics, and functional data structures. It helps developers write safe, composable, and declarative Kotlin code by leveraging functional concepts like option, either, and optics. Now, this is a very short way to describe Project Arrow. However, Project Arrow is a very broad, and it's becoming more and more and more extended, and it has more and more features that allows us to do all of this and more. And the key features here that we may want to use with our projects are the typed error handling with either an option. We may also want to use functional concurrency. There's an Arrow FX coroutines for structured parallelism. This means that we can use different functions that allow us to compose in different ways, different streams, and especially if we want to deal with them in parallel. Maybe we want to join one stream with the other in parallel, and we can do that already in Kotlin, but with Project Arrow, we can really make that code much easier to understand, and we can also make sure that our code base doesn't get too big. Resilience tools like retries, sagas, and circuit breakers. In this presentation, I'm just using sagas because sagas is something that revealed to be very useful. The other two and more different patterns that we can implement surrounding the theme of resilience, they are also very useful, but it is something that perhaps are more inclined to be used in a niche situation. But in this case, sagas is what we are going to talk about in this presentation as well. And then it also provides immutable data manipulation. And this is important because when we are using immutable data, we may want to change it. And that could be a cumbersome process if we are dealing with deeply nested data classes. And those data classes, especially if they are very, very deeply nested, can become a problem because I'm sure you've dealt with this before where you need to do a get before you put a set, and then you need to make a copy of a certain object, and then you need to make that copy in a way that that property is affected, and then you need to make the copy of all the different bound, sub, or other different nodes that are above. Parent nodes, the child nodes, you may want to copy everything, and that can be very cumbersome. With Project Arrow and optics, this works really, really easily, and I will talk about this in this presentation as well. So the overview of the project that we are dealing with is essentially this. We've got two different spaceships. They are communicating with each other. They're in space. They need to dock. They need to refuel. There are astronauts in them, and they both have a sender module and a receiver module. And essentially, this is just an overview of a project that is developing, and it's not finished, and it will probably never be finished because the project is intended to continue to explore the aspects and the different features of Project Arrow. But essentially, this is what we are having a look at today, and it is important that we focus here and bear this in mind so that we get a kind of atmosphere surrounding our code, because I think that helps understanding code a little bit better. So let's now find this in a more structured way. This is just a very simple diagram, and there's nothing special to it except that it explains the different topics that we are going to talk in this presentation. The first one is STM, that means software transactional memory. That is something to deal with different aspects of changing values of a state. So we will see how can that help us in making sure that our state doesn't get corrupted. We've got Arrow Core, which is necessary for us to use simple things in Project Arrow. Error handling, we're going to have a look at either, and option. Concurrency, how can we deal with different streams, and how can we deal with different coroutines being launched in parallel in different threads. Then we are talking about resilience. In this case, as I mentioned before, we are going to talk about Saga. And optics, how can we deal with deeply nested classes, and how can we deal with these instances and make changes to them in a way that our code doesn't get too big or too complex. So let's start with functional data modeling with Arrow Core. There are different features that we can use with Project Arrow that will help us modulate our data better. And one of them is option. And option allows us to deal with nullable values. We can already do this with Kotlin and other programming languages of the JVM ecosystem. One of them is using the traditional if. The other one with Kotlin is using the null coalescent operator or using the question mark when we are dealing with values. It's all about that nullability concept and the way to make null safety possible in Kotlin. But with Project Arrow, we can do that in a functional way. We will see that form further down in this video. Then we've got the concept of either. In a nutshell, either means that we have two different subtypes, a left and a right. On the left, we accumulate, or we put in the first error that we get by a function call, or we put the result of the function call on the right value of either. So either can have one or the other. And we will see how can we modulate this to our needs in our code. The other concept is data validation and error accumulation. So how can we validate data and accumulate the errors? Error accumulation is something that different frameworks already provide. For example, the Spring framework allows us to, for example, annotate different entities or different DTOs and accumulate all of the different validation results in a list, for example, or in a validation object. There are different ways to do that. With Project Arrow, we can do that also in a functional way, and that means that we can get all of the errors in an either type, where the subtype left will contain a list of all of these different errors. And those different errors will be inside a list of type NonEmptyList. And the reason for that, think about it. If we are getting an error, then we need at least one error in it. So it makes sense to use a NonEmptyList, or in its short form, null. But we will see that NonEmptyList can give us different ways to validate our objects, our DTOs, for example, if we need this kind of requirement. And finally, another thing that we want to have a look when we are modeling data in Project Arrow or with Project Arrow is this concept of lenses. Lenses are integrated in a more global concept called optics in Project Arrow, where it also includes things like prisms, but prisms, it's kind of a niche thing for a niche goal, and that goal wasn't applicable in our case. But lenses were, because lenses allows us to deal with data that is deeply nested. As I've mentioned before, it is important that we can shortcut the changes that we want to perform in our deeply nested data structures, should we use those data structures. So let's now have a look at the data model that we want to use to exemplify these different concepts. Now I've got here 3 different types: a transmission NG DTO, transmission new generation DTO, a message package, and a message. So the way this works is we've got a transmission DTO that has a message package. That message package is a package that wraps around a list of messages and a timestamp, and inside that list of messages we've got different messages of type message that will contain an ID, a purpose, a message BCC, and a message CC. This is just a data structure for an example of transmitting data between 2 spaceships. And we can see already that we've got this annotation right over here, optics in here, optics in here, optics, because these examples are also made to exemplify Project Arrow's optics, and specifically in this case, lenses. The first concept that I want to show actually is NonEmptyList. So let's begin with a simple idea. A list can be empty, right? What if I want the list to contain one single element and I want to validate that? What should I do? Should I just validate it? Should I use a validation function? I mean, that could introduce different side effects. And in a pure world, that is kind of risky to do, because I just want the list to not be empty right off the bat. I want to validate for it, but I don't want to use extra code for that. I want this to be as seamless as possible. This is where our hero comes in, our NonEmptyList, because it has a contract, and the contract says, I am a list which is not empty. And if we try to put a list that is empty there, it will just fail. So this means no more concerns about null values, no more empty headaches, and no more runtime surprises. So in our example, we've got a NonEmptyList that we are using in the class message package. But what's important here is that we first understand what this class is for. Now in detail, we've got a custom serializer, and the reason why a customer serializer is here is because Ktor doesn't give us all the serializers by default, and some of them we need to define manually. We will see this in the code, but it's not the important bit of this class. The important bit of this class is, of course, our hero NonEmptyList. And the NonEmptyList will validate that our list is not empty, as we have seen in the example. Now, if we look at our example now in the code, this is our example project. It's called Spaceship Parent, and Spaceship Parent is available on GitHub under my handle j.esperancinha, and we can find the source code of the project in this module app. And if we go into app, we will find the different structure related to the application that we are running. This is a service, and just to give you a general idea, I've got here the application starting with engine main. This is something that is related to Ktor, and if you are familiar with it, you know already what it is. But essentially, if you are also familiar with Spring Boot, it's just a way to start our application with all the context and every little detail needed to run Ktor. It's got here the different configurations that is necessary to run this application, but the important bit here is that we look now at the NonEmptyList. And if I just search for NonEmptyList, then I will see lots of different usages of this in the code, but the one that we are more interested in is this one over here in services. And if we go here, we will see that we have got the definition of message, and then here we've got the definition of package in Spaceship DTOs. And here we've got message package with serializable, which is needed to be able to serialize, optics, which is something we will see later on, our serializable here, another serializable here for local datetime, and this is the local datetime serializer. Now, before we continue, let's have a look at the NonEmptyList serializer. It is essentially a K serializer that implements 2 different important functions. These are the serialize and the deserialize. And here we can then see that our lists are correctly serialized and deserialized. This is important because we want to be able to send our data via the wire through our endpoints that will get the messages that we want to send. So if we go back, we've got here the most important part that we want to deal with right now, and that is the NonEmptyList. If we send messages with an empty list, this will not work. And if we send them with at least one element in them, then this will work. To test that, I've got different test cases for it. And let's just first see where this is being used. If we go into services and we go all the way to how this is implemented, this is essentially a service layer that creates different things for us. If we call these methods, for example, here, create transmission, it will create a transmission DTO in the database, and it will essentially return its counterpart, which is in this case an IDER that contains a transmission new generation DTO and a string. So here in string we will register in a string form our errors, and here we will register the actual value that we want to get from that function. But this is IDER, that will be for later. What we want to do now is test the route, and for that I've got one specific route that is specifically made for this example, which is spaceship routing. It could change in the future, but what it has now is a post request implementation, a post endpoint, which is this one over at transmissions, and it's called this one. This one over here is the post endpoint, where we will receive a transmission DTO this way. This is the ktor way to receive data from the endpoint, call.receive, and then here we create a transmission and we put it in the database. If something wrong happens, we will get an error. In this case, we will get an internal server error, or we will get a response. This is already using either, but for us the important bit is what happens between sending the request and the receival of the actual DTO, which is this one over here, the transmission new generation DTO. And in order to test this, let's just go to our scratchpad, which is this one over here. I've got here requests, and this requests.http is a file with all the different examples that we want to use to test the different parts of this presentation. So if we go all the way up to here, we can see that we've got a post to transmissions, the one we've seen before. Let's go back to it again and see if this matches. The route is called transmissions, this one over here. And if we go all the way down, we see that the node is the same, and then it will fall into this post endpoint, which is the one that we are testing right over here, where we are using http://localhost 8080 transmissions. Now, if I send this, it will fail because I didn't start the service, so I will start the service now. Cool, okay. Now the service has started. Let me just close this so that we can get a better overview of what is happening. We can see it's already creating different tables. We can see that it's creating the message packages, the messages, and the transmissions. In the background, this is using exposed. And this is akin to using the JPA in the Spring framework. But that's not relevant for the test that we are doing. What is relevant for the test that we are doing is that we send this request and we see now that no error is being reported. We can see that we have our data inserted in our database and we get the result correctly, because when we are returning the result, we are folding the IDER, and therefore we are getting either the created with an IT, which is the actual result, which is the transmission that has been saved in the database, or we get an internal server error. In this case, we don't get an error, we get everything correct. But what we are going to do right now is try to send a data without any single message. So in this case, we are sending messages, but we are sending an empty list. So if we send this now according to the new contract that says that our list must have one single element, this should fail. And that is what we are going to test right now in this point, where we see that it immediately says that it failed to convert the request body to the DTO that we wanted, the transmission ng DTO. And this happens, if we get a look at the exception, this happens right at the post transmissions, at the endpoint where we specified that we wanted to send the new transmission without messages. Because of course, if we are sending a transmission, we need messages. That is the whole point of sending a transmission. And so in this case, we've got an automatic validation just by using the type without the need to use any particular complex system of manual validations or just using annotations. In this case, the type itself validates for a non-empty list. But you may have noticed as well in the code, as I was running through it, that either seems to be using something, and that is something else. That is a non-empty list as well. But before I go into that, let's now have a look at either and what it means. So if we go here to the presentation and we go to the next slide, we will find the error handling example. And in here we see an example of using either. But let me tell you something about either. Either can be your new best friend in error handling, because handling errors don't have to be a headache. It is a reliable, no-nonsense solution to getting what you want, or dealing gracefully with errors when things go sideways. Imagine either as a two-sided coin. One side is right, where everything goes according to plan, and the other side is left, where all the error and issues live. But either makes them all feel welcome. Imagine either being that friend that never comes empty-handed to a party. So back to our slides, we can see that the example that we have here is a validate transmission function that returns an either of a string or a transmission ng DTO. String being the error and transmission ng DTO what we want to get, our goal, what we want to achieve from the call of this function. So that means that we return an either. And if you can see over here, we've got either, and then inside we've got the body of either. This is a function body that will perform different operations, and two of them are ensure. And this ensure over here, what it does, it simply makes a call to something that will validate something. In this case, it will ensure that the sender is not blank, and it will also receive as an input a function that will say sender cannot be blank. It will return a string, and that is the type of either. That is the type of the right in either. And then at the end, it will return the successful operation transmission ng DTO when all the validations have been successful. So in this case, what we've got here is the left and the right, as we have mentioned before. Left, a string, right, the transmission ng DTO, which could be anything. You could also use exceptions here. It doesn't have to be exceptions. I didn't use exceptions here because I want to make this as simple as possible so that we can understand this quicker. Then I've got also the either, as I mentioned before. This runs a computation block using raise and returns its outcome as either. So raise is the function that we are using here, and in raise we are using the ensure that will allow us to run these validations and make sure that our received object or our created object matches what we expect and validates the way we expect. We also have got this validations implementation, which ensures that the condition is met. Otherwise, raise raises a logical failure of type error. Now, sender is not blank and receiver is not blank is simply an expression that can return a false or a true. And that is the way we do validations this way. This is done in a functional way, and as you can see, if the code goes well, it goes completely from beginning to the end. There are no loops, there are no ifs, there is no return call, there is no throws, it just goes with the flow. An error that can possibly occur here will be stored in string, in the left value. And it will be accommodated very well, and either will give a room for it, a little house that we can then use for other validations along the line. We can then use fold map, different kind of functions that are typical and are available with either. But we may want to accumulate these errors, and that is what we will see in this next slide, where we can find a zip or accumulate function call. And the zip or accumulate function call is very interesting because we can use it in the body of either, and then we can then call ensure as many times as we want inside the validation function. So we can see now that the zip or accumulate will accumulate all the errors or the right value. But let's now see this in practice, how this works. So if we go to our project, we can then see that we've got here zip or accumulate. We've got here the insurer, the other insurer, and then we've got these two ignored input parameters. Now, the reason why I did this is because I want to highlight the fact that we can accumulate the errors, and then we can also create our object if all those validations have gone through, and if not, we return a list of the errors, which are now a non-empty list of all the strings that have been generated that are a part of the errors that occurred while trying to validate our object with zip or accumulate. But the thing is, in each one of these validation functions that we can add here, we can also return values. So let's say, for example, that I would go over here and say that I am returning A. So the last expression is A as a string. If I go here and I call this A, for example, we can see that this is a string now. If I say, for example, true, we'll now see that A is a Boolean. And this can be useful after validating functions, because I can also say here, for example, that I want to use a sender, and now the sender is a string, and I can return here the sender. I don't need to use the sender here as the input parameter of the function. I can perhaps use this here and perhaps make the code more readable. Or maybe use it in other different ways. We don't have to use it this way, but it's one of the ways that we can use this function as well, not only to accumulate errors, but to return values after each error has occurred or not. If an error does not occur, what value do we want to return, and where does this value needs to go to upon the generation of the object that we want to get, or what we want to get from the function when we are calling this. And remember, this is an invoke, so here we can also create an object of type transmission and GDTO. So now we see an example on how to use zip or accumulate, but we have not seen yet how does this actually work. So if I go here to the invoke test, then we can see the shape that this can take if we put wrong validation. So let's first look in detail what validations are we making. So we are making sure that sender and receiver are not blank. So in our tests, if we send on purpose senders and receivers that are blank, these ones over here, if I send this, I should get errors. And how many errors should I get in transmission and GDTO? So here, this, by the way, is not a transmission and GDTO. This is a transmission. This is more like an either, because remember, either will accommodate both errors and successes, and they are mutually exclusive. So that means if we get a success, we will not be getting an error. If we get one error, then there will be no success. And one error alone is a reason to create a list, which is a non-empty list, which has at least one error on it. All right, so now let's just run this test in debug mode, and let's see what happens in the result. Remember, we are now sending a transmission that has two errors, and when we get the validation, we should get just that, two errors in our transmission and GDTO, which is what we are getting here. We are getting two different messages. One says sender cannot be blank, and the other one says that receiver cannot be blank. So we are essentially accumulating the two errors with also the possibility of using results after performing the validation of each one of the fields that we want to validate. In this case, with ensure, we could just have added here something at the end, and we could have added here something at the end and use it here as the input parameters to create our transmission DTO or whatever we want to return in this invoke function. All right, so now we have seen the non-empty list, the null, and we have seen the either. And one of the things that in the presentation I didn't talk about in the slides is the option. And what do we do with this nullable thing that we have mentioned before? Let's now have a look at nullable. But here's the interesting thing about option. Knowing this, we can say that option combined with nullable provide us exactly with what? Let's face it, nulls happen. Sometimes the value that you are expecting is somehow sipping pina coladas in a parallel universe. But don't panic. Arrow's nullable function is here to turn your Kotlin mess into a functional bliss. Not only nullable, but also option. With nullable, you can embrace the void, and with option, you can embrace the none or the sum, where sum says, yep, I've got it, and none says, there's nothing here to see. And all of this without seeing a null pointer exception blowing up in your application. So nullable, I've got it in the project. I don't have it in the documentation. And we can have a look at it, for example. This one is an interesting one, but I have a better example of it. Let's have a look. Nullable, and then go to the project. And then I believe this one could be a good one. Yes, because this one, just first stop this. Now let's go to nullable. Let's go to, let's try this example. This is a good one. So this is a retransmission example. And what this does, it will check for every message if the message CC or the message BCC is null or not. If it is null, then what will happen is that the return of this nullable will be null if message BCC and message BCC, each one of them, if any of them is null. This bind will short circuit the function and make sure that here we will get a null value. So let me just first refactor that. Let's just call this a nullable result. And then here we can just, let's just print to the console the nullable result. So that means that if we happen to get a message CC with a null value or a message BCC with a null value, any one of them, then we will be getting a null value that will print out to the console value null. So let's now get the retransmissions endpoint in the example in the Scratchpad. So this is one that is retransmissions, and we can see here already that we've got message CC and message BCC with some values. And here we've got nothing. And here we've got BCC and message CC again. If we go to our code, we see that we have printed it, but we are also seeing an interesting thing. And that is that for each one of them that is successful, it will print out the full message to the console. If it's not successful, nothing normally would happen. It's just that now I've printed nullable result, and we should now see null in the console. So if I now call this endpoint with this message, how many full messages you think you will see in the console, and how many null values do you think you will see in the console? We will see one null value in 2 messages, right? Let's check if that's true. But before I do that, I do want to put some breakpoints here so that we see the short-circuiting function of this call. And let me just add to the example yet another message, which is going to be a message without a BCC. Because I do want to show the effect of short-circuiting. So actually, we will see short-circuiting before. Let me just get this one out and make sure that we do get a BCC, but we don't get a CC, because CC gets checked the first time, and that means that we will see it short-circuit way before. So now let's send this message and make sure that we can follow the code and that we can debug it. So let's now run that. We've got a connection refused because I stopped the service, so I will start it again. All right, now if I run the service now, I will see, we'll need to start it in debug. So I've got the service started now. If I run this, I've got the endpoint here, and I see now that we've got the first message that contains all of this, and the first message is the it message, and right over here we can see that it has the purpose, the message, the BCC, the CC, so it's got everything. So if I let it run towards the next message, we should see it printing out the complete message. Let me run it again to the next one. Now let's check the console and see what happened. In the console, we've got the full message that is being print it out to the console. So nothing much happened here because message CC and message BCC are not null. In this next message, if we see the result in the IT, we will now see an interesting bit, which is the BCC is null and the CC is null. So the first thing that we will see if we run one step further, this will now go back and will return a null, and we will print a nullable result. Go over here, it's already returned, and we've got a null result. Because one single value was null, it short-circuited here, and now we've got a null. The third message is a valid message because it's got a BCC and it's got a CC. So this one should go very smoothly, and it should go to print it out in the console. This will print each successful message 2 times. I made this very fast. So if I go here now, I should be getting this one. I've got this unit. I've got this one. Yes, because I am printing out to the console. Actually, let's leave it this way, because when we do a print, we return a unit, and that's why it is printing now a unit instead of null. But we can see the difference between one and the other, okay? So if we now run this one, remember, we are sending this message with a BCC, but without a CC. So if we do this now, and we run it, we will see that it short circuits immediately because it doesn't have a CC, and it will print out null to the console. So right now, we've got exactly what was expected. So we've got a message, we've got the unit that represents that a message was valid. The other one is a null because nothing was printed. The function was short-circuited over here in CC, which all of them are at this point with these examples. And then the third message we printed out correctly with the result of a unit after printing out to the console. And then the last one is a null because the last one does have a BCC, but it does not have a CC, and it's also being short-circuited here. But this is not option yet. Option is something different. Option is an example that I have here separately, and I did it this way because option is something that it's difficult to find a real use case to use option, because we eventually need to use option to transform our data, and when we are using that with the Spring Framework and JPA, we don't really use option that much, and so we are more inclined to use the null values. We are more inclined to use that nullable, but nullable can be used in the same way as option can be used, and with option we will see how this works right now, but with simple mathematical calculations. If I go here to compute and to the test that runs compute, I've got here an endpoint that says no binding and another endpoint that says binding. No binding means that we've got a non-value that will bind, and if this value is a no value, is a none, then that means that the binding operation will short circuit in the same way that nullable short circuits when the value is null. So bind here has that action, has that potential to short circuit the function if a match doesn't occur. And in this case, it's just a match with the none type. So option has got 2 subtypes, some and none. If it is some, then it's okay. Bind doesn't do anything. And if it is none, it short circuits the function back. So we've got this on an endpoint. And we also have got this in a unit test. So I don't really need to run to make this test. But the idea here is that when we run this unit test here, then what will happen with compute is that it will short circuit here and it will not return a plus b. Let's see what happens if I run this test. So if I run it, I see that the code has gone all the way to where I expected, to the b value. It will try to assign a value to b, but there's a bind here on a none. If it is none, it should short circuit. And that's what it does. It's already in the return. A plus b did not occur. And the return is a none. If we let it go, the test is successful because the return is just a none. No operation was made. Whereas in this case, we should be getting a sum with value 30. This is just a way to create sum in Kotlin with Project Arrow. So sum is part of the Arrow core libraries, and we can use it here very well. And if we do this, we will get a plus b, which in this case is 10 plus 20. If I run this now, we will see that no short circuiting is occurring, and essentially the result is 30. I can also debug it for you, and you can see that we've got 10, 20. These are two different sum values. And because they are sum, after binding them, we get the actual value. So this is a bit of redundant operation, but it's just here to give the example of what bind can do, because bind will only be able to be used in sum or none objects, essentially in option type objects. And then here we've got the sum of a plus b, which then means that 10 plus 20 is 30, so it returns a 30. And in order to be able to check that 30 works, this return is being made under option, and that means that the return will be sum 30. And that's why the tests run correctly. And now it's time to have a look at optics. And optics, it's a great thing. This is how we install it, but let me tell you a bit first about optics. Did you ever feel like you're navigating through a never-ending stack just to get that one value that you need for your code? Well, perhaps now you can just put down your shovel and pick up lenses from Arrow Optics. With only a few simple lines of code, you can modify your data without breaking a sweat or your brain. Say goodbye to boilerplate code and say hello to composable clean transformations. Lenses will make this feel and look like a walk in a park without having rabbits popping in from everywhere. But before we continue with the magic of Arrow and optics, we first need to know how to install this. And the way to install this is basically by using the KSP plugin, which needs to be installed in our plugin stack. And then we also want to have the KSP activation installed in our dependencies. Then we just need to use this in our dependencies in our build Gradle KTS file, or if you are just using Groovy, just build Gradle file. We also need to make sure that we are using the implementation that can interpret the Arrow Kotlin code, because there will be code generation, and that is the IO arrow-kt Arrow Optics. So essentially we've got a combination of three different important things that we need to configure in our build Gradle KTS file. One is the KSP plugin, that is the Kotlin symbolic processor, and then we need to have our optic dependencies in our dependencies, and we also need to activate the KSP plugin so that code can be generated. So what is this whole thing about code generation? Essentially, we are creating lenses for our data entities or DTOs. Wherever we apply that annotation with optics, that means that Arrow Optics in combination with this plugin in particular, and not exclusively this plugin, there can be other plugins that can do this for us, but when optics gets interpreted, there will be code generated that is the code that will allow us to use lenses so that we can access the different levels of our deeply nested data structures. This is our data model. And our data model is the one that we have seen before. It's the same thing. We've got transmissions ng DTO with a message package, and the message package contains a list of different messages with a timestamp included in the package itself. As we can see here, optics, this annotation is important to apply to every one of these classes. For each one of them, we will generate lenses that can allow us to access to them from the parent object. So here we go. We've got two different lenses. When we run this code and we build it, the generated code will give us these two lenses: transmission ng DTO message packet message and transmission ng DTO message package. What can we do with this? Let's see further on. We have these two lenses, and let's use, for example, message lens. And by using message lens, we are now able to access our object transmission, and we are able to get just the message package. So that means with a simple get, we can get the transmission, the full transmission, and just with that, we get just the message package. Maybe here we don't see exactly what is the advantage of using this, but whatever lens we have had in any of the deeply nested classes that we have from the parent class, would be able to be accessed with a simple get, and not with ... how many dots we would want, but that would be much more complicated than what we see here. And with a simple get, we get that data. But this probably is not the most interesting thing, because of course using ... is something that we sometimes do instinctively in our code. The best part is the set. And so here we've got the same lenses, and we are going to use the same lens, message lens, in this example. So if I use message lens set and say that I want to affect the transmission object and set the list of messages to be simply a list with one single message that has purpose, phantom purpose, and message, phantom message, what this will do, it will create a new transmission ngDTO that we can send back to the client that has the purpose and the message replaced by another message. And there will be a non-empty list of only one element, which is this element that we see right over here with ID 0 and package ID 0. So in one single line, we were able to change that object with the specific property that we want to change, because we've used a specific lens for that specific object. So now it's time for us to have a look at the example of this code. Right over here, we first can have a look at how the build is being set up. So if we go here to the build, we will see here all the way up that we've got the KSP plugin, the Kotlin symbolic processor, and then here all the way down we've got the activation of the KSP plugin, and here we've got Arrow optics also being used in our build file. This is important because only this way we can get optics to be generated. Now, this project has already been generated multiple times, so we should be able to find here in the build the generated objects created by KSP, and these are the objects: message objects, message package objects, and transmission ngDTO objects. And if we go inside all of them, we will find getters and setters. We will see a lot of different code that is Kotlin code, and we can see that this will take care of all of the different ways of accessing the deeply nested structure of our code. It will also include other things like lens, optional, traversal, and there will be lots of different things here that we can use. However, the most interesting part of it is to be able to change an immutable object, well, not change the immutable object, but to create another immutable object that is a copy of the original one with a specific property changed. And when we use set, the result is always the same object that we are trying to affect. It's just that it is a set from a lens to a property that gives back a copy of that whole entity with that property affected from the value that we put in as an input argument. All right, so let's see now how does the code is behaving. And if we go here to app source and we go here to, as we have seen before, the route, the spaceship routing, we will see different objects over here. And one of them that we are interested here is this part over here. Here we've got the post endpoint, which is called the phantom endpoint, where whatever message we send, we will be using the lens that we have created here above. And this lens is created from those generated files with the Arrow optics structure. And here it uses KSP to create that. And then here we've got our lens that we now use in our endpoint to affect the message that we want to give back and give back a phantom message. Let's see this in detail, and let's now debug our code and see what is happening here behind the scenes. So the service is already running. So if I go now to the example file and here I look for phantom, because we've got all different examples in this file, of course, and we want to make sure that we run the right example. So this one is located in the route pieces and then phantom. Let's double check that if that matches. Exactly. We've got here one route inside routing, and then we've got pieces and then slash phantom. So here we are going to land in this piece of code after reading the transmission. Let's do that. Let's run it. And now we've got transmission. And then here in transmission, if we run the debugging, we can see here transmission. We've got the result that we are sending. We've got the message package here with the different messages. And then there is only one message. And the message has purpose, message, and the message BCC and CC are nulls, and the rest is all null. It doesn't really matter because we are only just giving back a copy of this object with just a phantom. Now imagine if you wanted to change the messages, we probably would have to make a copy of the whole entity. So we would have to do something like this. Let's see, transmission, copy, and then here we would have to do something like message package should be the transmission, and then message package, and then what we also want to do is copy and then just say that messages equals whatever message we want to give it. And as you can see, this is like one dot is a copy, and there's no guarantee that we didn't miss any of the steps needed to create a copy of the same object with only that single property affected. And that is what Lens allows us here to do. We just do a set of the transmission and the list of the messages that we want to assign it to, and then we get a new transmission with the new result. So if we go over here and then we just let the code go, we should now be having two different transmissions. A modified one, which contains only the phantom purpose and the phantom message, and we should be having the normal one, which is now, perhaps I could do this, I'm not entirely sure. No, we cannot do that again. Yeah, we lost it here. Because we've got a coroutine there, and of course when we're trying to debug coroutines, this happens. We lose the information about the previous run, and therefore we don't have the transmission here at this point. We would have had if we would have called it, but that's not important. What's important here is that we are returning a modified version of this, and therefore what we've got over here is the new message with that phantom purpose. Now let's just check if it is the same message or not, by the way, if it is the same transmission. So if we go here to modified, we can see that we've got sender you, me, ID is null, and we've got this timestamp, which is exactly what we've got here, you, me, and the timestamp. Well, the timestamp is the current timestamp that is used when we create the object, so we cannot check that, but we can definitely check that the sender and the receiver are the same. So now if I let this run, then that should mean that in the requests, yeah, there's a timeout. Unfortunately, let me just run this again. If I just let it go right now, we should now be able to see that we've got a response, and that response is the phantom purpose and phantom message. So this makes optics a very powerful tool if you are thinking about changing data within an immutable deeply nested data structure and want to give back that modified copied version of the original one. All right, so this was optics. In our slides, we can now look at resilient communications with Arrow Resilience. But what is Saga and what can it do for us? Let me tell you about Saga. Managing long entangled workflows can feel like a chaotic game of Jenga. Because Saga is a transactional pattern that deals with different moving parts of a full, complete distributed transactional system, it is our superhero to handle these transactions that may not have a lot to do with each other, where we can, in each single point of action of these transactions, implement a rollback procedure if anything fails. And that means that those rollbacks can occur successfully on the first time that an error occurs in any of the single steps of a Saga transactional pattern. With Saga, the workflows are organized, atomic, and recoverable because of the rollback I mentioned before. Saga can be seen as a fail-safe transactional system with a back pocket parachute. The thing about Saga is that there are two different ways of implementing Saga. One is an orchestrated way, where you've got one single Saga orchestrated dealing with all the different sub-transactions or actions of a Saga pattern, and you've got the choreographed pattern where each one of them is responsible to give hand to the other next Saga action. In Project Arrow, we do the orchestrated one. Back to our slides. What's important here is that we understand that Saga is also an implementation and it's also code. So let's see. The first thing that we want to understand about Saga in Project Arrow is that there is a Saga builder, and the Saga builder creates our Saga pattern. And we can have multiple different actions inside Saga, which are these ones over here, which are these Saga actions. And in each one of these Saga actions, we've got two different parameters. One is the build body of a function that we want to execute, and the other one is the body of a rollback function to make sure that we go back if something happens. And the way this works is when one of these Saga actions fails, the other ones will also fail back. So that means it will go up to one point and then it will roll back if at that point an error occurs. The only point in time where the whole transaction occurs is when all of these actions are successful. And that way we can guarantee that we can get back to the initial state. So we need to be careful when we implement the successful action and when we also implement the rollback action, which will give us back the system in its initial state as best as possible that we can do. Because there's no guarantee also that the rollback is correctly implemented. That is really up to us to implement it in a correct way. Finally, to run the Saga and turning it into a suspend effect, we need to just call this transact here. In this example, I am using Saga under an either, and the reason for that is that I also want to handle the error. So here we see a good combination between using either and using Saga at the same time so that we can get either an app error or the fleet user in this case. Because what we are doing here is in multiple steps getting the user to be filled out with the necessary information that it needs. The only thing is that in each of the steps we are checking if the user has permission to get it. So for example, in the first Saga action, it tries to get clearance to get a telephone. If that's granted, it continues. If not, it will roll back everything that it has done before. And the same thing goes to the bank account number, and the same thing goes to the department. It's important that we understand that with a multi-step transaction, Saga is ideal for us. So every time we think about a multi-step transaction, if it is distributed or not, we will always benefit from using this pattern, and Project Arrow offers this right out of the box. But let's have a look at an example and see how this works. So if we go to our code and look for Saga, and we go over here, we find the exact same method that we have just seen in our slides, this register user by ID. And what it does here is that it essentially is ensuring things. It's making sure that it is using this raise inside this either. It's trying to ensure that original user is not null, for example, and raising and not found. And it's making all of these different checks. And the important bit is that, for example, in this Saga is the builder. And then here we've got one Saga action that will perform this operation if it succeeds. And if it doesn't succeed, it will then run this piece of code, which will then do a rollback. This is the rollback. In this case, I'm applying a nullable. Just in case that the original user is null, then it will fail, but it will not fail the rollback. It will just go back, and it will silently just ignore the fact that the user is null. And the same thing goes for all of the others. Now at this point, we should be able to understand already what this nullable does. So essentially, it returns null if any of the properties that are going to be bound are also null. So in this case, if original user is null, it will short circuit the function, and then it will return null to here, which gets ignored, and then nothing happens, and then it can proceed with further rollbacking. So let's now see this in real time. If I call this user's ID register, we should then be able to affect the current user and make sure that the user gets updated with the data that we need. We also got here at the top a get that will give us the current user. So let's see which user do we have there at the moment. Now this is not using a database in the back, it's just using a map, and that is specifically made so that we can simplify the way we see Saga implemented in our code. So if we now go to another file, which is called Saga requests, we will find the different examples that we want to use. The first example, I see that it is user 1, and I know this for sure that we've got a user 1 that will simply return, I believe, me. Is that me? That is me. At example.com with a null telephone and null bank account number and null department and null chamber. Okay, that's good enough. So now let's see what happens if we now try to send a request where I will try to put all of this in the code. So now we know that this is going to go via Saga. So if I run this, then what happens is that if I try now to get the user back, then the user has got everything filled in. So that means that the user has got permission to get all of its data filled in with the telephone, the bank account number, the department, and the chamber. Now let's go back to our Saga and let's purposely create a problem there. Let's just say that right at the very end, we are going to simply create a real big problem. Let's say that the user didn't got any clearance, and let's just throw here some exception, some runtime exception. And if this runs, then that means that the last step is wrong. So because this is all in memory, I can just restart the service and make sure that the user gets back to having null values. Let's see if that is the case. So if I go back here to Saga and simply run this, then I see that the user is back to having null values in the telephone, bank account number, department, and chamber. But now I am forcing a problem to occur at the last stop. And that means that when I run this, I will get a 500 internal error. But if I now try to run this get, the user hasn't changed because the rollback has occurred. And the rollback for all of the different actions has occurred. That means I do not have a chamber, I do not have a department, I do not have a bank account number or a telephone because the user was updated up until a point and then it got rollbacked from that point all the way to the beginning. But again, the responsibility to create a rollback is our own. All right, so this was the Saga pattern. Let's now have a look at something different. This one is a very simple thing that revealed to be very interesting and very useful in our project. This one is called Asynchronous data streaming with Arrow FX. Here's the thing. In all of this code, can you identify where the good use has been made with Arrow FX? If you pointed out to using this parZip, then you're right. That is what we are going to talk about in this very short bit of talking about the Arrow project. So parZip is interesting. And let me tell you a bit about parZip. If launching coroutines in parallel is something that you are interested in, another thing that you may be interested in is that your coroutines come back after running, and like a well-trained squad, they come back all together for the perfect photo. And you are interested in that, then parZip can be something for you, because it will wait for all the coroutines to come back together and get those results of all the different coroutines executions, pick them up, and make something new that you might be interested in. So parZip makes sure that the execution of different coroutines can be run in parallel, and we can get the results in the end after the runtime execution. So that means there are no early exits, no one first back wins, and it's kind of like a brunch where everyone needs to be seated first before we start our meal. And that is the power of parZip. So let's go back to the slides and see this in more detail. So parZip works in this way. There are two different functions, two different bodies of functions. One is the transmission service get transmissions by package ID, and the other one is message service get message package by ID. These two will run in parallel, and then their results will be picked up at the end with the sender timestamp function that receives these two parameters and then makes a sender message detail with the sender and the timestamp. Let's have a look at this in our code. So if we go to our IntelliJ right now, and if we look for parZip, we will now find that we've got this endpoint called purposes, and purposes, it will essentially create a sender message detail entity. Let's have a look at what it is. It is a DTO that has a sender and has a package timestamp. What's important here is that we can fill this out in any way we want. We will just put first the sender and then the package timestamp with the local date time. And of course we can see here the serializable with the manual serializable. We have annotated the class with serializable. And this is important. One thing that it's important to know that I didn't mention yet during this presentation is that serializable in this case is not really mandatory. It's just that I'm using Jackson and therefore I have to use the annotation serializable here. It doesn't have to be this way. We can use other different libraries, but that's the one I chose for this example. So serializable here is not really related to the topic of this video or even with Ktor itself. So let's now see. We are calling parZip, and parZip, if we go to the definition, parZip has many different ways of being defined. We've got here AB with another parZip, but we also have ABC, for example. We've got ABCD. So we do have different kinds of implementations of parZip, different overloading methods that will just use different function bodies that will run in separate coroutines. In this case, we can see that it runs via the coroutine scope with its default coroutine context, with the one that where they are in at the moment, and then we will get the combination of all of them into a type called E, and that E type is the type that we define inside the body of the function that collects all of the data of the different coroutines. So if we go back now, we will see that we will get the sender and the timestamp. But how do we get the sender? The sender we get here on the first function, which is by using this particular get transmission by package, and it will then get the sender from the package that has a certain ID. Now, let's have a look here first at this thing specifically with bind. So we've got 3 different binds here that will shortcut potentially our function because we are calling here nullable, and nullable here will send a message, will signal the contents of this to return null when one of these properties is null. So if the package ID is null, then everything will be null. If the package ID is null here, then everything will be null. It means that the result will be null in this case. So for example, here, if there is a null point here, then that means that this will all return null, and we will get the timestamp with a null value. And here the same thing, if we get package ID to be null, then we will get a null value for sender, but we will also get a null if the result of the get transmission by package ID is also null. So if we get no transmission here, we will not be able to get a sender, but this is covered here with bind because bind will shortcut this function, which will then return a null, and we will get a sender message details with a null value that will be sent back to the client with a null value. But that's not what's important here. What's important here is that we are using parZip to launch 2 different coroutines, one that launches this function and the other one that launches this function body. We've got 2 different function bodies that will be run in a coroutine context that will then be collected at the end to create a sender message detail object. So let's now see how this works in our code. So let's find the purposes example in requests.http. So if I go here and try to find it, I can see here a get. And if I use the get right now, I should now get, well, I get nothing because it's empty. So if I go here to routing and to try to get the purposes, then the get purposes will try to get all the messages from the service, and therefore this package ID that we would get from the messages is not existent, so there is no message. So that means that the sender message details will just be an empty object in this case. So it will be an empty list. Let me just correct one thing here, which is I can simply map not null. So that way we will not get a null value in any of the responses. So right now, the way this can work is if we first add some messages. So we can just go back to our example and just simply send one transmission. So if we go here all the way up and up to, let me just go back here, and perhaps it's also interesting for us to roll this back, and then here we can then send this transmission. And now we are putting this transmission in our database. This is actually a real database because it's going via expose. And so now, if we now run the same example in our requests, this get, that means that we are going to get one value, and that value is sender U with the package timestamp, because that's what we wanted to achieve. We wanted to achieve getting the sender of all of the different messages. We have sent one single message, and then we want the package timestamp. But the package timestamp, if we go back to our results here, we get the message timestamp by simply getting the message package by ID. So every message gets a package ID assigned to it, and with it we can find the package timestamp. So that's how this whole thing works, and that is how this parZip can be useful for us. And let's not forget that parZip has different kinds of overloads so that we can add more function bodies if we actually need them. So if we need 2, 3, 4 or more function bodies, there are functions that cover that in our Arrow library. All right, so this is the part of parZip. Now let's have a look at something that is interesting that I have actually already made a video about it, that is this one. I encourage you to go and watch it, but only after we had a quick look at the slides. So let's go to our slides. So that is about consistent state management with Arrow STM. This is the overview. And the way this works with Arrow STM is that we are trying to cover an example of keeping state in memory and managing state without corrupting it. So we want to make sure that our state is managed in a transactional way. This is different than accessing databases. It could potentially be used in combination with databases, with the different isolation levels that the database has to offer. But in this case, the most important bit is that we can manage state without a few of the inconveniences of normal locks. So what this does is we avoid problems with race conditions and with locks. So that means that we avoid locking our database, and we avoid creating a deadlock. How does this work, and how does this work particularly in memory management? So here we've got two different transactions, transaction A and transaction B. Transaction A is doing something and transaction B is trying to do something, but what happens is that in this particular case, both of them are successful and there's no particular problem. So this is the typical case. We do a read, we do a modify data, we commit. In both cases, everything is successful and everything runs successfully. But this is the easy bit. When it gets complicated is when we get across the first problem, the first, not even an error, it's more like the first conflict. If transaction A gets to modify data and transaction B modifies the data, by the time transaction A commits, it will be successful, but by the time transaction B commits a change to the same transactional variable, it will fail because it detects a conflict. But the great thing is that it will retry implicitly one more time to make sure and see if the transaction is successful or not. So basically, STM is based on retries and not based on locking and unlocking or releasing state or getting access or not getting access. It's just basically a retry mechanism that will manage the state in memory. And that means that we don't have the concurrency issue, we don't have race conditions, and we don't have any issue with deadlocks. In a more complicated case, we can see that we can get transaction A to modify data, and then transaction B will try to modify the data as well. It gets a conflict, it retries, but somehow then there could be another error, there could be another retry, there could be another transaction that is going to modify the same transactional value in memory, and that means it will keep on retrying until it's successful. There is never a period where it keeps retrying forever, because that's just not possible. It will retry until it achieves to commit or until there is an error. So there's no retries if there's no transaction occurring changing the state of a particular transactional variable. There is only a retry if that happens. But of course, at some point, all of them will have retried. So at some point, there will be none of them busy with retrying because the state has been changed. And they will fail if there is an actual failure. So there will be no retries on an actual fail, not on a state change, but on an actual fail. But how does this occur? Well, here's the data model that I've used. It's a very simple one. There's just two different types. One is docking bay and the other one is fuel station. And these ones will change when we apply tvar on them. So docking bay and fuel station on their own, they are not transactional variables. They are just simple types, simple variable types. But when we apply tvar on them and initialize them that way, then they become transactional, and we are able to use them in a transactional software memory way. So let's see what happens now. But let me tell you about software transactional memory. Have you ever wished that your threads would cooperate rather than fighting for resources? STM in Arrow allows to do just that. With STM, you can run all different concurrent operations as if they were part of one big happy family. STM in Arrow brings you the power of transactional memory where actions are atomic, isolated, and consistent. So back to our slides. Talking about consistent state management with Arrow STM means that we also need to understand our code. And for that, here are the examples that we are going to have a look at in our slides. Remember, the video is available, and please have a look at it because it explains all of these examples in detail. So I'm not going to repeat the practical case of these examples. So consistent state management in this case. What we've got here is a late init var called docking bay and another late init var called fuel station. These are all declared as transactional memory variables that are initialized by using this initialized function where we can start them with certain values. The idea here is that we are calling this initialized from another way of creating services in Ktor, and that is using Coin. And Coin is just another library that allows us to use injection in Ktor. It's not really important for the example, but the idea that I want to give you is that I created these variables somewhere in memory where they are now transactional. And that means that we are only be able to use these transactional variables with the use of things like atomically or STM, which we will see right now. So to run a transaction to completion, we use this atomically function that will then receive a body that we will define, and then we are able to process it. The way it works is that since we are using docking bay as a transactional memory variable, that means that it has different functions and methods to be able to change its value. One of them to read is called read, and the other one to write is called write. And there we see our docking bay right over there where we read the value, and if there is enough space in the docking station, then the ship can park, and that means that the ship will occupy that, meaning that the state of that value will be changed after committing. And committing means reaching the end of atomically. In the same way, we can break apart one single transaction with the use of STM. STM can be placed inside of atomically so that we can separately create different separate transactions so that we can perform changes that we want to achieve. For example, here in the fuel station, we are trying to fuel our spaceship independently so that we can keep control of how much fuel is still available and how much fuel the ship is allowed to take. And with STM inside atomically, we also are able to provide a fallback. That means if something fails, what do we do afterwards? So for example, if fueling fails, what can we do? Should we use another fuel station? Should we try to use the resources? Should we try to use some kind of storage that we have inside our own spaceship, or use some kind of alternative green energy, for example, in our spaceship? These are alternative things that we can do should fueling fail in this case. So it is very complete. We can use atomically with an STM, which provides more extra functionality and not only just doing different transactions inside another transaction. Another thing is when we are talking about failures. When we are talking about fail, in the example that I gave in the other video, is that if there is a fail, then the transaction stops. And that's what we see over here if the requested fuel is 20. This is just for tests, so if I put a 20 to the fuel, that means that it will immediately throw this illegal state exception, meaning that the transaction will stop, there will be no more retries, and we will finish the transaction with, unfortunately, a failure. And that's what this atomically does. So this means that by throwing this error, the transaction will stop and nothing will be changed. Now, as a conclusion, which is important now to get everything together. Saga. What is Saga? It enables a robust transactional workflows in distributed systems by handling compensations and rollbacks. It is true, we saw in the example that we can perform different operations where we need to validate each one of the different operations, and if anything fails, it will fail back to the initial point. We will be able to reset to the start point of our transaction. The only thing is that we need to be very careful so that the rollbacks are working correctly so that we can get back to the initial state. Then we've got nullable. And nullable, we have seen that we can use this with option or with null values directly. If we want to use null values directly, we can just use the nullable function. If not, we use option so that we can use option, which has then the two different subtypes that we have seen, the none or the sum. We've got either, which allows us to deal with errors in a way where both the errors and the results that we need to get are held together and are accommodated in our either object so that we can deal with them and perform safe operations in a functional way. We have also seen optics, which provide us, of course, a way to deal with deeply nested data structures that are important for our system, and we that way don't have to generate so much complicated code, which of course is always the goal when we are implementing code and we are implementing services. We don't want our code to be too extended and we don't want to have too much complexity. And of course, we want to make our code as simple as possible, which is something that Optics provides very well. The only disadvantage perhaps is that we need to use plugins and we need to choose a specific kind of plugin that can process symbols. And we also need to use the library that Optics provide, because otherwise it will not be able to interpret our classes. And of course, it relies on code generation, which can be a hassle when we are generating our bytecode for our services to work. We've got zip or accumulate, which is a great thing in combination to use with either. We can accumulate all of the different validation problems and put them in a single list that we can then choose to be either a string, which is the most simple case, and I do not recommend using string, but we can use exceptions for it, and we can put all of the different exceptions that we have got. But when trying to access a function, put them there, and then we can process each one individually. Maybe we want to give them back to the client, or we just want to process them and register them in a database, send them to a monitoring framework. Whatever we want to do with it, it is a very interesting thing to use. Finally, STM. STM provides safe composable concurrency without logs, without race conditions. STM allows us to deal with all of the different data that is held in a state, that is held in memory, and allows us to do transaction management without the need for isolation levels or any kind of optimistic or pessimistic locking. It's just a mechanism that is based on retries, automated retries, and we see that implicitly in our code. Again, this video explains very well the different steps, and I explained there how the example works and where can we see the retries happening and how can we see the retries happening, although that's not something that it's necessary to do, but I did it for the example so that we understand exactly how STM works. All of this is something that we can see in our projects. It's something that we can use in our projects. These are things that we found out to be the most useful for everything that we are doing. I think this is something that can be a generic template to use in many different projects. We can have an approach of trying to use everything that Project Arrow provides, which is, I think, an unattainable goal, because not all of what Project Arrow provides is something to use in a generic way. There are niche potentials there, and we need to make sure that we do have those niches in our project if we want to use those interesting things, like, for example, prisms, which is a very interesting topic of Project Arrow, but of course it doesn't fit the general usage that Project Arrow can have for our production environments. Questions. I had a ton of questions in during the presentation in London. I had 3 particular questions, and they were all very interesting. There was one question about either being deprecated in Scala. This is something that I need to investigate further in another video. I wasn't expecting that question. Either is very much used in Project Arrow, and we use that a lot. And we see a lot of advantages in using either. So that is an important, interesting aspect. Perhaps Scala doesn't want to use either anymore. I'm not entirely sure about that one. So it's a good topic for investigation. The other question was about debugging. If we could debug things with nullable, option, or either. Yes, we can. We have seen in these examples that we can basically debug everything, and we can see the results going in. The only thing is that we are always facing that problem with Kotlin coroutines. If we are having coroutines in our code, then we lose the debug points from the coroutines if we are past the point of the coroutines running and we don't hold a reference to those variables. And finally, there was a third question about STM, about software transactional memory. It was more about how the hell does software transactional memory doesn't get locked, how deadlocks do not happen. Well, again, the video where I talk exclusively about STM explains that in detail, but in general terms, because it is a system based on retries, locks will never happen. And I also explained this now in more detail because I wanted to focus on that question and make sure that that question would be very clear what the answer would be for it. And of course, STM, because of the retry mechanism, there will never be a lock. There will never be a transaction waiting for the other because one will always finish. And if it doesn't finish, it retries until all of them have finished. And then the only possibility that one of those transactions will not succeed is if at that point an error occurs. Otherwise, it will be successful and the commit will be successful. These are the resources for this project. It's called Spaceship Adventures. It's available on GitHub. It's available under my handler, J. Espenensingen. These are the resources that you can check out to learn more about the meetup, about Project Arrow, about Kotlin, and of course my own website. Then about me, so I have this homepage, which is joaophilippe-sabine-sprensinger.nl. It's my full name. LinkedIn, you've got YouTube, Blue Sky, Mastodon, GitHub, HackerNoon, and DevTO. So this is where you can find me. If you want to pop in a message about this presentation, I really appreciate that. And for the last bit, I just want to thank you, the viewer, for watching this video. Congratulations for reaching this point. I want to thank the London Kotlin community for giving me the opportunity to speak there at the meetup. I found it a very different way, an interesting way of giving a presentation because it was done online. We have photos of that and a small video about the questions that were being made. I found it to be a very interesting and rewarding experience. And I learned a lot from it. And one of the things that I've learned is how to speak to the silence, because there were people listening to me, but I couldn't hear anything of what they were saying. So I was literally feeling like I was talking to a void where I really wasn't. There were lots of people listening to me, but the silence was so extreme that it was difficult because I really liked the interaction with people, but it went really well. In the end, actually everyone really heard really well what I was saying, and the microphone worked really great, and all of the connections worked really fantastically. But again, it's a different experience just speaking to a screen and speaking to the slides and thinking that people are listening to you. And they were, because the questions were great and people were very enthusiastic about the presentation that I gave there. So that was really nice. Yeah, I really want to thank the Kotlin London community for this. I want to give a special thanks to David Kraft for keeping contact with me. We actually contacted via Blue Sky, and then all of a sudden we were talking about this in Slack, and then it finally resulted into having this presentation being done online in the London Kotlin community. It was a bit of a shame that we didn't get around to get everything in order and correctly made so that I could travel to London. But hey, no problem. It was still great. It was still amazing and really nice to be able to give this presentation in online for the London community. All the details of this meetup are available in the description. Make sure to read it because I also put the links to anything that is relevant for this presentation right over there, including the link to the STM video with Ktor and the other Ktor video that I made, so that we kind of understand all of this stuff that I've discussed in this video, especially if you are coming from a different kind of world, like the Spring world, and you don't know much about Ktor. It is important also to have a look at this video over here, where I talk about the basics around Ktor and why is it important for us to understand and learn more about a different way of creating services. And make sure to give us a like. It helps a lot if you give us a like, if you give us a bit of a comment in the comment section. And make sure to subscribe if you enjoyed this video, because I have a ton of videos and a ton of ideas to put in this channel. This channel is always moving. There are more busier moments than others, but that's life, and sometimes there is not much time to make videos. In the coming period, there might not be too many videos being posted on the channel, unfortunately, and that is because there is going to be a very busy time for me in the coming weeks. And until the next video, be sure to stay tech, keep programming, be kind, and have a good one. Bye. I've updated my disclaimer to better reflect my position. This video is not sponsored and I have not received financial compensation for its content. Any brands, products or companies mentioned are for informational purposes only. While I may participate in various programs, meetups and conferences, all opinions expressed here are my own.